Hi guys, welcome back to the channel. I made some progress in choosing some parts for the front end. Now, because I decided to take out the mixer, I have to process everything at the RF frequencies. So I don't have the benefit of choosing, amplifiers which they have low bandwidth. But I found a very nice ADC driver and variable gain amplifier, which is designed exactly for this kind of application. It's a bit overkill for what I want because it has way larger bandwidth than we need, but it's a very nice part for future projects. So it did cost me some money. I think it was about 150 euro. I bought the demo board for this part. It's a Texas Instrument part, but I think it's a good investment in the future. Now, for amplifying the signals from the antenna levels to some decent level where it can attack the VGA, the variable gain amplifier, and the ADC, I choose some tiny little ICs from Texas Instruments, which they come in different flavors for different gains, and I send some PCB Gerbers to GLC PCB because I need to build them in so many variants, and if I was going to buy the Texas Instruments demo boards, I would spend too much, to build so many frequency variants. I prefer to have something customizable. Now, I'll go straight to the data sheets and show you the parts. And there is an entry on the blog if you want to see. I documented there the parts if you want to have links to the data sheets and so on. So those are building blocks, so it will help me to, plug things together and configure and reconfigure and make experiments. Okay guys, so I'll start with the RF gain block, which they're just tiny little amplifiers. So this is how it's called. They come in different flavors, so this letter actually tells the gain. They come in, 12, 15, 18 and 20 dB. So it's a very neat part, very simple part, nothing fancy about the part. They're cheap. I mean, in large quantities, they're, $50, something like this in 1,000 units. So they're not expensive. They are matched to 50 ohms. Of course, you need to change the components depending on your frequency range. But simple part, nice and cheerful. Now, they have this PCB, like a demonstration PCB, but I need to buy many of them, so it's getting into hundreds very quick. So what I decided they give you the Gerbers, so they are Gerbers, you can download the Gerbers. So I decided to just place an order with GLC PCB, so I'm expecting them somewhere next week. Now, the variable gain amplifier, it's a different story. It's not a cheap part, as you can see here. This is the part. It's not a cheap part. It's $20, 20 euros in small quantities. I would say 22 euros. But it's a very interesting part and very promising for future projects. So I'll show you here the datasheet. So this is how the part looks like. So it has a differential input, differential output, matched to 100 ohm. So you need to use a balloon here, balance to unbalance, or the other way around, depending on the input or output. If you want to work with the single-ended, now this part is actually designed for wideband ADCs, which all of them, if not most of them, they have differential inputs. So this part is actually perfect for good ADCs, which we are going to use in future projects. Now I have to convert from differential to single-ended. But anyway, not a big deal. Now this part has, I'm just going to here on the first page here, it has fantastic figures of merit, so it's DC to 4.5 gigahertz, which is plenty for us. And it keeps that, about the programmability. So this part, the gain is programmable via SPI. And the nice thing is actually it has very good range for gains. Must be a table somewhere, I hope. Yeah, here. So you can actually program from 26 dB gain to minus 6. So it gives you a span of 30 dB, right? So you can, why this part is necessary? So it's necessary because you want to make sure that your ADC it's driven to the full scale. So if you have a small signal, it might stay in a few LSBs. But if you amplify and you take advantage of the full dynamic range of the ADC. So this part it's a must. You can't get away without it. Okay, so I think this part, just going a little bit further with this part, there is a demo board for this part. As you can see, it's not very cheap. When you add the shipping and tax, it's getting into 150. But as I said, I'm going to use it for future projects. So yeah, here is a better picture of the demo board. Now this board has a small USB to SPI bridge on the PCB. So, and there is a small application you can download from Texas Instruments, so you can set the gain. So yeah, that's it. I don't want to make a very, very long video saying nothing, just for the sake of making videos. I ordered those parts, PCBs and all that, so I should get them pretty soon, probably in a week or 10 days from now. And we are going to experiment a little bit with the amplifiers and with the signals. The only thing which I think is missing from the whole thing is probably an LNA, low noise amplifier. But we'll get to that when we get to that. Okay, that's it. Not much to say, just that. I shall see you in the next one.